Okay, so the first thing you want to do when reading a scientific text is to try to figure out the author's purpose in writing the article. What is the author trying to tell you? And a good way to do this would be to look at the title. So the title here is The Rate of Photosynthesis, Limiting Factors. So I'm going to try to break this title down and figure out what it means in everyday language so that I know exactly what the author is trying to show me. So this first part, rate of photosynthesis. So rate, what does this word mean? Now, when I think of rate, the first thing that comes to mind is heart rate. And I know that heart rate has to do with how fast my heart is beating, kind of how many beats per minute it's going. So I know rate has something to do with speed. And now the second part, limiting factors. So limiting, to put a limit on something is kind of to restrict it. If I were to limit the number of candy bars I were to eat in a day, I would be capping myself at a certain number. So after breaking this title down, I know that the author is going to be talking about factors that restrict the speed of photosynthesis. So the next thing I'm going to do is to be looking at this subheading right here, light and rate of photosynthesis. So I'm just going to infer that light is probably one of these limiting factors that's somehow affecting the rate of photosynthesis. So before you read the article under the subheading, a good thing to do would just be kind of to think about what might be the relationship between light and the rate of photosynthesis. So I'm going to use some of the prior knowledge that I know from what we've been talking about in class on the relationship between light and rate of photosynthesis. So I know that photo means light. If I were to take a photograph of something, I'd be capturing an image using light. And the second part of the word, synthesis, means to put together. So I know that in this process, light is what's putting all of the reactants together to form the final product, which we know is energy. So I'm just going to assume that light, an increase in light, is going to cause an increase in the rate of photosynthesis. And as I read, I'm going to be testing my hypothesis that I've formed. And also, looking off to the side, I notice that there's a graph that's showing the relationship between the rate of photosynthesis and the intensity of light. And from these two arrows, I know that this graph is to be read in two directions. Reading it in an upward direction is showing me the rate of photosynthesis, and as the line moves from left to right, it's showing me an increase in the intensity of light. So as I read, I'm going to be referring back to this diagram to try to see if I see any connections. So at low light intensities, as light intensity increases, the rate of the light-dependent reaction, and therefore photosynthesis, generally increases proportionately. So in that statement, I noticed a relationship between what the graph is showing me, rate of photosynthesis and intensity of light. So looking back, it says as light intensity increases, photosynthesis also increases. So now I'm going to look back at my graph and see if I can see this relationship that I read about in the graphical display. So increasing the rate of photosynthesis would be the line moving in an upward direction, indicated by that arrow, and an increase in light intensity would be the line moving from left to right, which is indicated by this arrow here. And I see that relationship right here with the line moving both up and to the right simultaneously. So reading on, the more photons of light that fall on a leaf, the greater the number of chlorophyll molecules that are ionized, and the more ATP and NADPH are generated. So these two right here, ATP and NADPH, we haven't talked about that in class, so I'm going to use some textual evidence to try to infer what these two words might mean. So looking at the line before, it's talking about an increase in the rate of photosynthesis. And I know that the ultimate goal of photosynthesis is to generate energy. So since it's saying that ATP and NADPH are generated due to this increase in photosynthesis, I'm going to infer that these two words just mean forms of energy. So now I notice that there's this other part in the graph that hasn't been discussed yet, so I'm going to read on and see what the article has to say to explain that part of the graph. So as light intensity is increased further, however, the rate of photosynthesis is eventually limited by some other factor. So again, I'm seeing a relationship between the rate of photosynthesis and the intensity of light, which is being shown in the graph. So as light intensity is increased further, it says that the rate of photosynthesis plateaus. So looking at the graph, I see that right here. Light intensity is increasing as the line moves from left to right, but the rate of photosynthesis isn't changing. The line isn't moving up or down. So that statement matches with that part of the graph. But I also noticed as I was reading that it said that the rate of photosynthesis is limited by some other factor. Now the text doesn't come right out and tell us what this other factor might be, so I'm going to make an inference. So I know that light is only one part of photosynthesis. I know that the other two reactants are water and carbon dioxide. So light is going to put these other two reactants together. So maybe since there's an abundance of light, yet the photosynthesis rate is being limited, maybe there's not enough CO2 and H2O for the light to put together to increase the rate of photosynthesis. So that could be the other factor that's affecting the rate of photosynthesis in this situation. So now that I'm done reading this portion of the text, a good thing to do would be to ask a question that might further my knowledge and that I could investigate through an experiment. So what I've been wondering throughout this paragraph is, okay, so light is one of the parts of photosynthesis, but what about the other reactants? So from what we've learned in class, we know that light plus water, H2O, plus carbon dioxide, CO2, all go together to create energy in photosynthesis. So this article talked about how light affects the rate of photosynthesis, but I'm wondering about how these other two factors might affect the rate of photosynthesis. And this might be something I want to investigate through an experiment.